With the default cube selected, go to the Modifier Properties tab, click Add Modifier, and select Bevel from the Generate list. You can immediately see the effects of the modifier. Let's toggle into Edit mode and show edges. The default setting is edges, but you can also set the modifier to bevel vertices. There are several options for width type, and each calculates the bevel a little differently. To get a clear idea of how each type functions, let's toggle into wireframe mode and disable the modifier in viewport shading. We'll mark out where the original edge exists. Now, when we re-enable the modifier for viewport rendering, we can see in front view how the bevel has been applied. In offset mode, the amount is measured from the original edge back along the direction of the adjacent face. If we switch the type to width, the bevel is measured between the two new edges formed. Switching to depth, the amount is measured from the original edge to the newly beveled face. Absolute is similar to offset, calculating the bevel a set unit away from the original edge. Finally, percentage will calculate the bevel as a percentage of the adjacent face length. In this example, 5% happens to be the equivalent percentage to the offset amount. 0.1 of a metre is 5% of 2 metres. The bevel modifier has a number of limit methods to calculate what is beveled and what isn't. The default setting is angle. The specific angle in question is measured between the face normals of adjacent faces. If you want to see this clearly, let's tab into Edit View and enable face normals in Viewport Overlays. I'll move this edge over. Now if we project the face normals until they meet at an angle, we can measure that angle and see it's about 59 degrees. In our bevel modifier, if we set this angle to 59, any angle above 59 degrees will be beveled, and any angle below it will be ignored. You can set a number of segments which curve the bevel between the newly created edges. The higher the segment number, the smoother the bevel. The profile for the bevel is set to super ellipse by default. This can be modified between a maximum and a minimum value, which correspond to the position of the original edge and the point where the edge is beveled. We'll change the limit method to weight. We'll have to assign a weight value to specific edges that we want bevel. I'll toggle into Edit mode, select an edge, and using Ctrl-E to bring up my Edge Specials menu, I'll set the edge weight to 1. Now, only this edge will be affected by the bevel modifier. Let's change our bevel profile from super ellipse to custom. Instead of a factor, we now get a curve, which shows the profile of our bevel. Let's use one of the presets available to us. If we select Support Loops, the custom profile will be created using the number of segments and width type that we have already selected in the bevel modifier to draw out the curve. If we change any of the above parameters, the custom profile won't be dynamically updated. We'll need to reapply the preset to make the new profile. Sampling straight edges and even lengths are two settings which calculate the average of the bevel between the new edges. But in cases where the segment count is low, these settings will approximate the bevel based on the profile. The more segments you have, the more accurate your profile will be. Now let's take a look at miters. There are two types. An inner miter will be formed along a concave edge, whereas an outer miter will be formed along a convex edge. Under the geometry setting, each miter has various modes for calculating how the bevels are smoothed out. The outer miter can be set to sharp, patch, or arc. By comparison, the inner miter only has two settings, sharp and arc. Increasing the spread of the miter will affect inner and outer miters. Let's reset our limit method to none. Intersections where three or more edges meet at a single vertex can be set to bevel at one of two modes. Grid fill, in which the corner will be beveled with a smoothed grid in accordance with all previous settings, or cutoff, in which the bevel creates a face which will meet an intersecting beveled edge depending on that vertex's normal direction. The bevel modifier also has some neat fixes which are enabled by default for when things inevitably go haywire. These are best shown by disabling them on the kinds of objects where these situations may arise. This Susan monkey head has the bevel modifier added to it. If I disable the clamp overlap, the width of the bevel is disregarded. Enabling it accounts for surrounding topology and will scale down the effects appropriately. Loop slide is important in special cases where you have n-gons formed by a Boolean function. Here I have a cube with a Boolean modifier set to difference, and the modifier is targeting this smaller rectangular shape so that a window is formed. I'll now add the bevel modifier on top of the Boolean. Loop slide is enabled by default. If I select the Boolean object and move it around, you can see how the bevel around this window scales proportionally. But if we disable this, then the bevel around the window remains equal, regardless of where the Boolean shape is positioned. Under shading, we have a few different settings which correct for different situations. I've added the bevel modifier to this headphones object. Now, if the shading on the object is set to either flat or smooth, this is usually a default. When you enable harden normals, you'll get this warning message telling you to enable auto smooth in object data properties first. So let's go ahead and do that. Here is one place where you can find the setting. Hardening normals won't change the topology, but rather how the lighting interacts with the affected faces. By matching the normal direction of adjacent faces, problematic shading is corrected. Marking seams and sharp edges corrects problems that might occur when you finally apply the modifier. Let's mark some sharp edges and some seams. In Viewport Display, I'll make sure we can see these when we enter edit mode. I'll duplicate the object, and on the original, I'll leave the marks disabled. Selecting the duplicate, I'll now mark seams and sharp. Let's now apply the bevel to both objects. If we shift select both and toggle into edit mode, we can spot the difference. When the modifier is applied, the generated sharp and seam marks are corrected for. This could lead to some undesired shading or UV unwrapping situations down the line. The material index will allow you to assign a material to only the beveled edges. Let's add a second material, and let's tinker with the settings. Finally, there's the face strength settings. This is definitely one with a few surprises. On its own, you're not going to notice any perceivable change between the face strength settings. But if we add a modifier which requires face normal data, let's say weighted normal for example, then the face strength settings come into play. Now we can better see how altering the weight of the normals will affect how the surface reflects in scene lighting. You'll see here that the bevel modifier is higher in the stack than the weighted normals modifier. So when we alter the face strength settings, the bevel can set the influence on whether none, new, affected, or all faces are influenced by modifiers which depend on face normal data lower down in the stack.